Now in this video, we want to look at limits of trigonometric functions. Okay? Alright, so we have the following trigonometric functions. We have sine of x, cosine of x, tangent of x, secant, and so on like that. So all those are trig functions. So let me give you their full names immediately. This is sine, right? We put it down as s. So that is the sine. We're talking about sine of x. So in short, we just write sin. Good. And then this is cosine, all right? The complement of sine, cosine, and then this is tangent, right? Then this is secant. Secant is actually 1 over cosine, and then this is cosecant. It's actually 1 over sine. And then this one right here is cotangent, that is 1 over tangent, right? So those are the trigonometric functions in which the angle, okay, of each of those are denoted by x. The angles, they are the inputs. So when you have the input of a function being an angle, then that function possibly going to be a trigonometric function. Good. So these are all trigonometric functions of x. All right, great. So we want to look at the limit of each of these as x tends to a certain value, all right? I'm going to denote that value as c. Okay, let's say that value is maybe possibly not in the domain of the function because limit is not really concerned about the definition of a function at a point. Okay, so this is the limit. Let's start with the sine function. So the limit of sine x as x approaches some real number c. Good. Well, the result here is going to be just by substitution. The result is going to give us sine c, right? So as x approaches something, you just substitute that thing into the position of x in the function. So we're going to look at another, which is going to be cosine, of course. The limit of cosine x as x approaches c, right? The result here is still going to be cosine c. So maybe you can do the rest. For tangent, say limit of tangent of x as x approaches c, just going to be tan c, and so on for secant, cosecant, cotangent, all right? All right, good. And again, I would like to show you some trigonometric identities. I'm not going to show you all because there are millions of them, but I'll just show you few trig identities based on these six trig functions that are going to be very, very necessary, right? That will help us in evaluating limits of some trigonometric functions. Oh, good. Okay, the first one, which is very common, is tangent of x. To be the same, we can rewrite this tangent of x in terms of sine and cosine, all right? And that will give us sine x over cosine of x. Good. Then note that when you hear of cosecant, which I've written out there, of x, it is gotten from 1 over sine. So if you have the sine of a function, then cosecant will be the 1 over that result you got, right? So let's say this is going to be, let me write another one out for you. Secant, okay, let's say secant x, all right? This is 1 over cosine, all right? So when you have cosine of something, then 1 over that result is going to be secant of that same thing. Good. So the last one here is cotangent, which of course is 1 over tangent, all right? 1 over tangent of x. And you notice that tangent of x is sine x over cosine x. So this tells us that cotangent is going to be cosine of x over sine x, all right? That's just by inverting this fraction. All right, good. Okay, with this, we can, let's see, with this stuff here, we can say, let's see the certain number or a certain value. Then as x approaches that, you see, you observe where sine is approaching, where cosine is approaching, and so on like that. Good. Maybe let's do that real quick. So let's look at the limit as x approaches 0, right, of sine x. Well, this right here tells us as x approaches something, just plug that in. So if you substitute 0 in place of x here, you're going to have sine 0. And you should know that sine 0 is equal to 0. So this is going to be sine 0, which is just 0. All right, good. The next thing we'll do here is the limit as x tends to, let's say pi over 2, right, of cosine of x. Well, this is just going to be, by substitution, we're going to have it to be cosine pi over 2. And cosine pi over 2, well, pi over 2 is an angle measured in radians. We can also convert that to degrees, right? Where pi is the same thing as 180 degrees. So pi over 2 will be the same thing as 90 degrees. And cosine of 90 degrees is going to be 0 also. So if you want to look at another example, maybe look at tangent immediately. We have the limit. Let's say x tends to pi over 4. So if pi is 180 degrees, right, then pi over 4 will be the same thing as 45 degrees. Let's look at tangent of x. Well, the result here is going to be tangent of pi over 4. And if you know what that is, well, this is equal to 1. So the result of that limit is 1. So this is just a very simple, these are just very simple examples where you just need to substitute the value x is approaching into that trig function and evaluate. That's all. Good. Okay. In our next video, we're going to solve examples that has some trig functions, and we're going to make them a little bit complicated for you, all right? But we're going to break them down using these simple facts, all right? Okay, great. All right, thanks for watching. Please subscribe to my channel.